Hello class, these are Algebra 1 notes for section 6-7. We are still building quadratic functions to describe situations. So we've looked at patterns that give us quadratic functions. We've looked at maximizing the area given an amount of like fencing or perimeter. We have looked at projectile motion, and now today we're going to look at revenue. So quadratic functions often come up when studying revenue. Revenue means the money collected when someone sells something. So it's profit. I guess not just profit, right? It's going to be all of the money that you get when you sell something. Let's see if I can get my pen to work. There we go. Suppose we are selling raffle tickets and deciding how much to charge for each ticket. When the price of the ticket is higher, typically fewer tickets will be sold. Let's say that a price of D dollars, with a price of D dollars, it is possible to sell 60 minus 75 D tickets. So our price is D dollars, and it says 60 minus 75 D tickets. That's going to be like our number of tickets we sell. So, and it makes sense that if you charge more, less people will buy them, right? And you could also say that if you don't charge very much, like maybe you only charge $1 or something, and then people think that maybe it's not worth it to buy the raffle ticket, right? Maybe they don't think they can earn very much, or if it's make very much off of the raffle, or maybe whatever you're selling isn't very good if they're only paying $1, right? So there's going to be that sweet spot in between where you're charging enough that people see value in it and they want it, but you're not charging so much that it kind of scares people away from buying it either. We can find the revenue by multiplying the price by the number of tickets. So we want to take and multiply our price by our number of tickets. So let's remember our price was D, our number of tickets was 600 minus 75D. So a function that models our revenue, R, collected is D times 600 minus 75D. And this might not look like a quadratic, but think about if we distributed D. D times 600 would be 600D minus D times 75D. Well, D times D would give us D squared, so we would have 75D squared. So let's remember, whenever we have that variable squared, like that, we've got D squared, our variable squared, our input is squared, it gives us a quadratic. And so that's why we have this kind of a shape that we're looking at. So here we have a graph that represents the function. So you can see, like, if I sell my tickets for $1, we have, it looks like about 500 that we would actually, $500 that we would actually sell and make, right? Versus if we sell them for $6, it looks like we would sell a lot more tickets. Maybe about like 900 at that point, right? So that's how my graph is working. I've got revenue and I've got the price that I'm selling the tickets for. I'm sorry I'm moving this around so much. I just keep erasing. So what is our greatest possible revenue? Well, that would be our maximum, right? Our maximum is right here at the top. And if I trace this over to my y-axis, it looks like my maximum revenue, the most amount of money that I could make off selling these tickets, is going to be $1,200. So the maximum revenue is $1,200. And this is when we sell tickets for, let's see, let's trace this down to our x-axis. It's when we sell the tickets for $4 each. And then we want to look at our domain and range as well. So let's remember our domain is all the values we can have for input for x. So I'm looking at that x-axis, which is really a d-axis here. It's that price in dollars for our tickets. So it makes sense I can't have negative numbers for the price of a ticket, but if I look at my graph here, I have everywhere between 0 and 8. And it makes sense that I could have decimal numbers, right? I could charge 25 cents for a ticket. So we're going to say that 0 is less than or equal to D is less than or equal to 8. So we're kind of sandwiching the D between the 0 and the 8 to show that it's between those two. Now, granted, I wouldn't want to sell them for $0, right? And I wouldn't want to sell them for $8 either because I don't really make any revenue that way. But those are all the values I could have for my domain. If we're looking at our range, our R of D, revenue, so R of D up here, it looks like it's anywhere from 0 to 1200. And it looks like that's actually in thousands, so I'd have to add a few more zeros to that if I'm understanding that correctly. So we'll leave it this way. That's the way my formula works. So again, I could have decimal numbers. 0 is the least I could make. 1200 is the most amount of money that I could make. So just a little review of domain and range. So we're still continuing to look at these quadratics and really think about maxes and mins and x-intercepts and y-intercepts and domain and range. So we're kind of looking at these graphs and using all of the vocab that we used in the last couple chapters to describe graphs as well. And we are looking at a new kind of equation here, like a revenue equation, where we multiplied a price in this case by the number that we were going to sell. So a new application. So as always, if you need help, please make sure that you're getting it. Please ask.